Okay, let's see this question. The question is today's challenge. So you can see it's medium level question. The pass with the maximum probability. So you can go through this one, and then if there is no pass from start to end, just return zero. Otherwise, we need to return the most probabilities. So you can see here. So the start node is zero. We need to start from zero, and the end is two, right? So now we had two paths, right? We can start from 0 to 1. Okay, we take 0.5 probabilities. Now 1 to 2, so we still have 0.5, right? So we need to 0.5 times to 0.5, we got a 0.25, right? And then the second part is we can directly go to the 2 from 0 to 2. This one is take 0.2 probability. But we know 0.2 is smaller than the 0.25, right? So we need to pick the bigger one. So let's try here is, and then now here we can see the companies. So like the Google and the Amazon, this company recently asked me question. I think you need to prepare. Now coming to here. So if you know the question is the graph question, so which means we need to build the graph, right? How to build a graph? Well, so many way. My way is using a hash map. You can understand this one is the key. The value is the least because we know the one node can have multiple neighbors, right? Not only one neighbors, multiple. So here, naturally, we need to use the least for the as the value, right? Now here is zero. We know zero can go to one and a two. So here we have the zero and the two because we know the no zero can connect to these two neighbors, right? Now we come to here. Now we have this one, no one is one. So we know one can go to here. Let me use different color here. So we know one can go to here and here. So they have two neighbor, right? Can zero and two, right? And two also have two neighbor. It can be zero and one, right? So after we create this one, this bowl, on this table, right? Oh, sorry, it's one. And then we need to the array with size of n. So we know the n equal to 3. So now, why we need to this array? The array used to calculate the maximum probability for each node. For example, we know we start from zero, right? Okay, we can put the one here because we need to start from here. We cannot put the zero. We know the zero times to any number equal to zero. So that's why here put one. Because it's one, it doesn't matter because we only need to know the end node like that. So we don't need to care about the first node. So we can put one here, and then so 0 to 1, so we know it take 0.5, right? So let me remove this one. 0.5. It's 0.5, right? So now 0. We know here is 0 is we start from 1, right? 1 times to 0.5, we got here is 0.5, right? Because here is the original the value is 0. So 0 always smaller than 0.5, right? So we can update the value with the 0.5. Here also is the default value is 0. So that's why I didn't put here. You should know here's 0. And then now we got here. Now we have pointer here. Now we need to vector our labels of no 1, right? So he can go here and it can go to here. Okay, forget if here first time go to here, 1 go to the no 2, we know it's a no, right? So here 0.5 times to 0.5. Okay, now we know here it should be 0.25 because 0.25 is greater than 0. So that's why we need to update here. Now we know here each node have 2 paths, right? 2 direction. So it can go back here. So now we know here is, so what is the probability here? It's 0.5, right? Because we can pick the probability from here. The probability here 0.5 times to 0.5 to 0. So we need to reach the no 0. So we got the 0.5 times to 0.5. We got the 0.25, right? So we need to comparing this one. We know 0.25 smaller than 1, so we don't need to update here. So we just key in the 1 here. So now we finish this part. So here, before I mentioned here, they have 2 parts, right? We just finished this part. The node also can directly go to the A node. Okay, A node. So we just take the 0.2. The 0.2 is smaller than 0.25, right? So we cannot use this to update the 0.25. So finally we just return this one. So that's why the question we can use the HashMap to build the graph. And the second step, we need to create an array to maintain the maximum probability for each node. And third step, we need to use the BFS because we have Q, right? Q can go through each list. Okay, now let's start coding up. So now we have the HashMap. And then we have the pair. So we need to create a pair class. Because we need to create a graph, right? Pair. Can understand? No. Double pair. And double with the probability. Then this no equal to no. And then this equal to. Now we come back to here. Now we need to go through this edge because we need to build the graph. And now we equal to, okay, now we got the 2 node, right? And then equal to success. So here I create one pointer. Also here you can use the just provide the I, create an I in there here. So up to you. I just create here. I now here we need to create a HashMap. Oh, 1 second. Map. Before we go into here, we need to create the list. It's fine. Let me do here. So we know we have 3 lists because here we have 3 nodes, right? So you can see the node is start from 0, 1, 2. So here we also need to start from 0, 1, 2. everything depending on the n. Now we need to create a new pair. Right now, when you finish this one, oh sorry, it's double. Now after here, we need to get a u.add pair v. Okay, now because each node have two direction, right? You can see here is undirected graph. So that's why we need to copy this one. Here need to provide a view and a use. Now we finish the graph. Now we need to create an array. Oh, it's not stable. Now we know we need star node equal to 1.0. And then we also need to create a queue. The queue needs to start from the start node. Right. Should be now queue.add start node. We need to check the queue is not empty. Yes, we get a no, and the queue the poll. Now since we got the no, so we need to next step we need to get a list, right? This pair is get no. And we need to go through this neighbor, right? And okay, pair list. Now we know each pair contains two fields. Now we need to index node, next node, right? Sorry, it should be that node and double. Probability, yeah. Now we finish this one, and then we need to calculate. Now we need to. So here already we cannot use the probability. Let me change the name as label. Yeah, now yeah. Before I use the while loop here, it should be for loop. Now we need to calculate the probability for the both node. So here we can I is node next node equal to time to current node if the next node is smaller than so it is not stable. Okay, understand number. If here if next node smaller than current, can understand current probability. Okay, now next here. Okay, now we need to update this one. Here we need to get the maximum one, right? And then next step we need to add a queue the next node to our queue. And finally we need to return and no. Okay, now let's run it. Oh, okay. Fine, because here I didn't include the I pointer. Oh, hold on. Okay, you can see pass on the test case. So here you can see it's big 65%. Now I would say the time complexity is B of n because I just go through the n only once. You will not hear saying I go through I using the 3 for loop here, 2 for loop, 1 while loop. But the time we need to pick, I think here is B of n. Yeah, now we can, you can see here it's all n here. So and the space complexity is B of n because I just go through. I need to store each neighbor, each node in the queue and the hash map. So yeah. So thank you for watching this video.